three zeros of polynomial functions. So first we have the factor theorem, which says that for any polynomial function f of x, x minus k is a factor of the polynomial if and only if f of k is equal to 0. So if you plug in the value of k, when you get x equals k, then that should be equal to 0. The rational zeros theorem. If p over q is a rational number, and if p over q is a 0 of f, a polynomial function with integer coefficients then p is a factor of the constant term and q is a factor of the leading coefficient. You're not going to be able to be fully committed to both. There's no way.
Well, volleyball. That was the agreement.
I know, but that's what I'm saying. You're not going to be able to be fully committed to both.
Oh, I see.
The fundamental theorem of algebra.
Maybe I could just leave the game early. Skip the fourth quarter.
Every function defined by a polynomial of degree 1 or more has at least one complex 0 the number of zeros theorem. A function defined by a polynomial of degree n has at most n distinct zeros and the last theorem is the conjugate zeros theorem, which says that if f of x defines a polynomial function having only real coefficients and if z equals a plus bi is a 0 of f of x, where a and b are real numbers, then z equals a minus bi is also a 0 of f of x. So sometimes they'll tell you a plus bi, or obviously there could be numbers in there, not letters, is a 0. Then they may not necessarily tell you, like, by actually writing it that a minus bi is 1, but you just need to know if there is a 0 that has an I, then its conjugate also has one, the a minus bi.